So my presentation today is on implementing co-opetition with BACnet. And the long title is How Facility Managers, Specifiers, and Equipment Suppliers Can Use BACnet Effectively in a Multi-Vendor, Smart Grid, Smart Building Environment. So, learning objectives. What is co-opetition? At the end of this presentation, you should be able to understand how BAS vendors, how BACnet allows BAS vendors to bid work in a competitive manner while cooperating to meet the owner's needs. And be able to describe the network controls design model we're going to discuss that allows for multi-vendor co-opetition to work effectively. I'm going to outline the roles and responsibilities in project plans and specifications for the various parties to a construction contract. I'm going to outline the model components that make co-opetition possible. I'm going to explain how network controls design model co-opetition can be implemented successfully. And I'm going to describe how BACnet can be used to specify the 4 smart grid devices: the energy manager, the meter, the load, and the generator following co-opetition. And we'll detail how BACnet devices and suppliers of these devices must work together to meet the requirements of ASHRAE 201P. So let me introduce myself. Appen Associates is a 33-year-old consulting firm. We specialize in building automation system design and specification. And we do mechanical systems design, HVAC, boilers, chillers, paying a particular need to attention to the needs of facility operations. I'm a professional engineer. I'm a member of ASHRAE SSPC 135, the BACnet Committee, SGPC 13, the Guide Spec Committee, and I'm active in ASHRAE 201P, which is the Smart Grid Committee. ASHRAE is my professional society, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. Okay, co-opetition or cooperative competition is a term suggested by BI President Andy McMillan. It refers to the ability of the owner or facility manager to use ASHRAE BACnet protocol to permit more than one BAS vendor to provide BAS goods and services in a multi-building site, such as a university campus, a military base, school district, so on. And BACnet was founded on the principle if vendors A front-end software can talk to or interoperate with vendor B's BAS devices, then it would be possible to build out or renovate buildings on a campus or on a base in a competitive manner by bidding the work to more than one vendor. BACnet's history has demonstrated that vendors, even though they are competitors, will cooperate on a job site to ensure that each company's equipment will interoperate properly on a common BACnet network. Previous speaker yesterday, the professor from Arizona State, talked about transparency, and that's one of the critical issues that makes BACnet so successful. Specifying BACnet compliant devices has allowed the owner to manage the transition from a sole source to a multi-BAS vendor environment. Many of you may have had one vendor because it was a proprietary system, and if you wanted to competitively expand that system, you either had 2 islands, 2 different systems that couldn't talk to each other, or you had to rip out the first guy to put the second guy's controls in. Both options aren't very good in this environment. And co-opetition means that both VAS vendors and equipment suppliers who have equipment with BACnet interfaces can provide BACnet equipment on a competitive basis. So, in the project's plans and specifications, how many of you are involved in construction and the renovation or whatever, where you have to get, you're renovating a space or you're building a new space, whatever? Okay. And there are roles and responsibilities for the designer, the owner, the general contractor, the BAS contractor, and other parties such as the electrical contractor, the equipment supplier, and the commissioning authority all must be clear. These contracts go on for quite a long, there's a lot of paper with respect to them, but what's important is that we have to define the roles and responsibilities for each party to the agreement. The BACnet requirements must be clearly identified for each piece of equipment that is to come with a BACnet interface. I'm going to use that term BACnet interface, but what it means is that when a device presents itself, I'm presenting myself, I'm Grant Wichenko, I'm so tall, I've got gray hair and so on. Okay, there's my interface, okay? At home, I may speak a different language. Here, we're all speaking English. There must be a proper object list or list of points for each piece of equipment so the supplier knows what to provide and the BAS contractor can properly estimate the cost of creating graphics, trends, alarms, and schedules. With the coming of the smart grid, that's the utility interface where there may be real-time price changes and your facility has to respond to real-time price changes or potential power outages. It's an issue in California, less so in other parts of the country. Equipment will provided in the facility domain, that's referred to as your building, and must operate in this domain and will eventually need to share meter, generator, load, and energy manager data outlined in ASHRAE 201P to allow the facility domain as a whole to respond to real-time pricing and demand response events. How many of you are involved with doing demand response at this point or real-time pricing? Do you have to respond to that at this point? Anybody? Well, stay tuned. I'm going to talk briefly about the transition of stick building to network controls using BACnet. Stick building means equipment comes without controls. The BAS contractor fits up the controls in the field. So you get an air handler, a boiler, what have you. Big dumb box goes on the housekeeping pad. The controls contractor fits up the device with controls. BAS systems are now interoperable from the operator workstation, from the damper actuator to using the BACnet standard for interoperability. So devices and equipment are now coming with controls on board. And now equipment suppliers who used to offer other protocols like Modbus now offer native BACnet devices. So you can get native BACnet. It's not just VAV boxes, but lighting systems, fire systems, and they will present to the network as a BACnet device. So now, devices such as chillers, boilers, generators, switchgear, lighting, fire security, and other equipment now come with network controls on board. Just like in your car, the mechanic just doesn't lift up the hood and look around. He plugs it into the computer to do diagnostics to find out what's wrong with the car. We do the same thing now with boilers, chillers, switchgear, variable speed drives, all sorts of devices. So, at one time, okay, all controls work was done by the HVAC controls contractor, as only HVAC systems really use controls. The network controls design model is based on the principle that equipment provided by the electrical, fire, security, lighting, and other trades comes with BACnet on board. So now we're buying a device that's network aware. One of the things that we have, and that should be required, is that field installed gateways not authorized by the equipment supplier are not allowed. And what that means is that I don't want the controls contractor and the equipment supplier at the end of the job sitting down, screwing around with the gateway, trying to make it work. Now, there are many vendors that I sell equipment that are new to BACnet and may have hired a vendor to provide them with a gateway to communicate between their device, existing proprietary protocol, and BACnet. The issue is that the gateway is supplied by the device supplier, so that even though it's a co-gateway, okay, it is integral to the boiler, the chiller, or whatever device you're getting. I don't really care that it speaks Swahili in the background. I want it to speak BACnet to the network. and that there's a single desk responsibility for the supplier who provides that gateway. So there's a clear line of responsibility between the device supplier and the BAS vendor who is responsible for monitoring or controlling the equipment. And so what that means is that if you're a BAS vendor, okay, your job is not to try and get the gateway to work. Your job is to plug in and say, is the gateway operational? Because I know when I talk to BACnet, using BACnet, I can discover the device, I can discover the points, I can see what's in the box, and I know that BACnet's going to work. There are also safeties, UL, and other code requirements that must be respected. Making a network connection instead of hardwiring to the device or fitting controls on the device by others must respect these requirements. So for instance, where we're dealing with fire alarm systems, there is UL 864 that requires you to, you can't really screw around with the fire alarm system. So the fire alarm system BACnet interface is basically a read-only interface. You'll see the status of the smoke heads and the heat detectors and so on, but you can't go in and start shutting these devices down unless you are doing it with a UL hardened workstation and maintaining the UL chain of continuity to the device. The network control specification must tell the equipment supplier that he's responsible for the BACnet interface. This is not the responsibility of the BAS or the third party. So a lot of equipment suppliers, when we do work with them, we've been doing this for about 5 years now, okay, you mean I have to provide the BACnet interface as well as the box that's on the housekeeping pad? Yes. And we've had to educate the local suppliers that their responsibilities extends to providing the BACnet interface. And the BACnet interface gets approved via the submittal process, like the color, the weight, the electrical requirements. So as an example, I get, well, we're going to order the chiller, and at some point we'll get around to sending you the BACnet interface. And I said, well, you're not getting the chiller submittal approved. And the guys looked at me and said, well, what does it matter? I said, if I said to you, if you're the supplier and you said to me, I'm not going to tell you what the voltage is of the chiller, the electrical contractor can guess at the time the chiller arrives as to how he wires the chiller, would you expect the submittal to get approved? No. Oh, no, we always say what the voltage is. Well, BACnet's just electrons flowing at a different voltage. Like, get past this, right? And if you want me to go to your website and download the data for you, okay, put it into your submittal format and hand it back through the submittal food chain, I'll do that. So it's getting the suppliers used to the idea that the BACnet interface is integral to the submittal, because the BAS contractor needs to know whose device am I getting? Is it 10 objects in that box I got to map into my system? Or is it 100 objects in that box I got to map into my system? So mechanical electrical subtrades must ensure that they're acceptable submittals and that the equipment for the BACnet interface is installed and commissioned properly. So it now becomes integral to the building system that the BACnet interface is part of that submittal. And the general contractor, who doesn't care about BACnet, okay? All he cares about is making sure the job gets done, customer's happy, and he gets paid, okay? His responsibility, though, is to say to his subtrades, you know, Mike the mechanical or any of the electrician, okay, that you must meet the specification requirements that includes a BACnet component. Don't bore me with the details of objects and MSTP and all this other stuff. If the submittal doesn't get approved, the job gets delays, okay, and then there are problems in terms of there may be delay claims or penalties that I have to pay. How do we do this successfully? Controls was originally scattered throughout the 16 master format 1995 divisions. How many of you know what master format is? Division 15, Division 16, okay. With the advent of Master Format 2004 and now 2012, Division 25 integrated automation is the logical home for building automation systems. Division 25 is the vehicle to provide controls and networking information for devices specified in other divisions, such as 7 shading devices, 11 lab controls, 14 elevators, fire protection, plumbing and HVAC, electrical, communications, security, and other divisions. So let's look at a simple BACnet interface to a boiler. Why would we want to do that? Well, we get to find out a whole bunch of information that simplifies maintenance and enhances sustainability. We learn about supply air temperature, fuel pressure, flame signal, O2 value, combustion efficiency, okay, gas volume. So now we can do real-time energy metering of how much the boiler is burning. We can also meter the boiler electrically to know how much electrical energy the boiler is consuming. And so remote monitoring and diagnosis is a green, sustainable plan that saves maintenance and travel costs. So let's apply the network controls model to the BACnet interface. A condensing boiler is normally specified in 235200. What we've done is we've created analog sections for each master format section throughout the 48 divisions. So in our spec, we have a division 2520, 2352. And the reason why we did that is we only want Bob the boiler guy, Chuck the chiller guy, and Ernie the elevator guy to go to one section to find out what the BACnet requirements are. We don't want them trying to figure out in the construction document, well, there's 10 different places you got to look, because when you're bidding a job, you're lucky to even get your own section, let alone something about BACnet. So if the equipment is in 23NN, which is mechanical HVAC, the BACnet interface is in 2520NN. Now, we could put all of the BACnet interface on the condensing boiler in the equipment section, but normally this requires extensive design coordination. We often do the controls part, and then there's an MEP consultant and an architect that does the design of the building. So we basically work with them, they do their design, and we do the networking and the BACnet component. So there's only one reference for the equipment supplier to find out what he or she needs to know. So we coordinate work between 25 and the electrical divisions. There may be an IP drop for that BACnet IP device that is specified in Division 27. And let me digress for a minute and say we don't want the BAS contractors doing IT cabling. We want this to be part of the enterprise. We want structured cabling to be done by the structured cabling contractor. If we need 25 IP drops to make our BACnet system work, that is built into Division 27, and that way the cabling is done by the trade that's responsible for all cabling in the building. And we've created a Divisional 1 section to make sure that the GC, who is responsible for means and methods, coordinates the trades for this interface as and any other BACnet interface device. So here's a boiler specification. So what we do is we give the mechanical consultant, so it's 2352, and we give him references in the related section to tell the equipment supplier where to go to find out the BACnet information. Okay? Because if you don't do that, the supplier is going to say, well, I didn't know about that. And that's a fair question. We want it to be transparent. We've got a section that says controller to be fully BACnet capable, interfacing with the building DDC system, and so on. And then we've got a section, what we call a language adder, and it says provide a BACnet interface device for each heating boiler, so the units are presented as a series of BACnet objects. See 2520, 2352 for the list of objects, and any actuators, sensors, valves, and so on are conform to Division 25. Because for those of you who are designers, often a code requires a valve on a condensing boiler, okay? That valve is not to be supplied by Division 25. It is to be supplied by the boiler supplier as part of the safety equipment tied and controlled by the boiler, not by Division 25. Okay, so here's an abbreviated list of how our spec works. So we've got the boiler in 2352. So in 2520, 2352, we give the list of boiler objects that we expect to see and what the boiler management system is expected to do. Okay? Often with condensing boilers, for those of you who design systems, it's not unusual to have 3 or 4 condensing boilers to allow for staging of loads, right? The consultant designs the job for a design day, the coldest day of the year, but that's 2-3% of the time. Generally, you want to have it both for boilers and chillers. You want to be able to stage on your load as you need it and stage off your load when you don't need it. So there's a boiler manager, a traffic cop that says, okay, you run, oh, you're in fault, okay, it's your turn to run. Now, with respect to the objects, at this point, every boiler supplier has a different suite of objects. So we try to be flexible and say, our list is probably 100 different things, okay? If we're approving a boiler submittal and the boiler supplier comes and says, I got 1 object, well, we're not going to approve that. But he may have 80, he may have 120. So we are flexible in that way so long as it's meeting the consultant's design intent. So these boiler objects include things like fault codes, supply water set point, gas volume, runtime hours, and so on. And we're doing this because there's no way we could instrument a boiler or chiller to get that kind of information to meet, for example, the measurement and verification requirements for lead. Okay, it would be very expensive and difficult to do that without being able to do BACnet, having a BACnet interface that included metering. We've created 5 BACnet device types. A single onboard BACnet device, such as a generator. A built-up BACnet device, such as an air handler. Remember, you could have an air handling unit that's got a VFD that's got a BACnet interface to it, a humidifier with a BACnet interface to it, a gas section with a BACnet interface to it. The flow station, okay, is now a BACnet interface. Okay, so now what you're doing is you're creating a local area network for all these devices. And so there has to be rules about who supplies what, who installs what, who networks to whom, who provides power, and so on. You could have a plant controller. The best example of that for those of you who do server farms and you do crack unit cooling, computer room air conditioning cooling, you never buy 1 crack unit. You always buy 2 for redundancy. Because if you lose your cooling in a server farm, like, there's a lot of problems. So there has to be a plant controller that says which one runs, how long does it run, and do I need both of them to run? And so what you want is you've got a local area network of devices that control that plant. One of the essential issues with the network controls model is that each system must stand on its own, assuming the network never works. So the fire alarm system runs on its own, chiller plant runs on its own, the air handler with the VAV boxes run on their own, okay? And we have IP connections to these devices, but they have to be able to run on a standalone basis. We could have a network BACnet device, and the distinction there is between the built-up or the plant controller is that a network BACnet device, such as a booster pump with VFDs and a pump controller, you could have like a booster pump with 3-speed drives. it's basically just networking that's done there as opposed to providing any power. And finally, you could have a traditional stick-built device. So each device type has a set of trade responsibility that defines who supplies what, including line power, who wires and terminates what, who provides the cabling. So we don't want to have this conversation in the site trailer. I didn't allow this in my scope. Okay, we want to avoid change orders, and this work is potentially fraught with lots of change orders. And I can tell you right now, our process has very few change orders. So why does this process work? Well, the network controls design model specifies the BACnet interface that comes with the equipment. The equipment supplier is responsible for the BACnet interface, not the controls contractor. Now, I have seen on jobs, the equipment supplier will hire the controls contractor to do the interface, okay? That's fine with me. As far as I'm concerned, the controls contractor at that point is working for the supplier. He may be the Division 25 contractor, okay? But he is working for the supplier. And I don't really care if that happens or not. Contractors have an easier time finding the BACnet interface as the boiler section references the boiler control section. So what that means is that Bob the boiler guy and Chuck the chiller guy and Ernie the elevator guy only go one place to find what they need to know. And designers only need to make a few references in the corresponding location to basically pointer language, like I showed you on the screen, that points from the equipment section to Division 25. Design liability is clarified if the Division 25 spec is provided by other designers. Okay, we're not telling the designer how to design the system, okay? The designer picks, I want, 2 million BTU boilers or 4 million BTU boilers or whatever. We don't really care what the designer picks. We're concerned about, does the device talk on the network? Similar with the chiller plant. You got 3 chillers, 4 chillers, 5 chillers, whatever. Pick whatever you want. Our job is to make sure it talks. Your job is to make sure it works. The installation, wiring, and other work responsibilities are clear. In the old days, and I'm sure Ben from KMC will tell you, if there's a wiring problem that has anything to do with low voltage, it's your fault and your responsibility to do it. Because that's what we're used to doing, okay? Even if it's, we've done jobs where the door controller on a hanger was low voltage, and somehow that became the controls guy's responsibility, even though nobody told him to do that. There's no playing around at the end of the job with gateways when the when the general contractor is trying to close out the job. And the commissioning process is simplified as each component is tested separately. So we test the boiler. Does the boiler fire? Is there a boiler test report saying it fires? Okay. Okay, now we make sure, is it communicating? Okay. Is it communicating to the boiler manager? Okay. And is the boiler manager communicating to the building automation system? So if the building automation system sends the boiler plant, say, I want 120 Fahrenheit water, what happens is that the boiler manager then says, okay, you're going to run, you're not going to run, you're in fault, and I'm going to get you to run next, okay? The building automation contractor is not controlling the boilers directly, it's controlling the plant. If I got a 1,000-ton chiller plant, and I need that plant to make 42-degree water because it's warm outside, I send the set point to the chiller plant controller. The chiller plant controller then says, okay, 42, all right, you're going to do this, you're going to run at 50%, you're in fault, okay, you're on deck. Once all of the components are tested, then functional performance testing on the building systems can be done, knowing that each of the individual pieces of equipment are operating correctly. One of the things is in order to do functional performance testing, there must be objective tests to make sure that the components are working, so that we know that if we don't have enough air, or the building can't cool, the building isn't cool enough on a design day, okay, that it's not the controls problem. And when we combine this with a secure remote internet access plan, network control saves transport energy and maintenance and labor costs. So if those of you are facility managers, we want to talk to IT about authorized contractors having access to their equipment, because remember, the actual person that knows something about the equipment, okay, may be hundreds of miles away. And it's a huge cost to get on a plane to fly there just to look at it, when he can be in Acapulco laying on the beach on his smartphone looking at how well the Hobart 400 hertz unit is working in a hangar somewhere, some Air Force hangar somewhere. Network controls design model allows facility operations staff to have access to faults and statuses to all major components in the equipment in the facility. So for instance, the boiler supplier may say, I've gone in, I've looked at it, okay, there's a part that we need to order next week, I've got it working for the time being, I'm out next week, I'll bring the part with me and I'll fix it then, as opposed to, we gotta do something right now. Okay, we want to get away from that. And when these high-performance buildings, things must be kept running all the time. Okay, there's not a lot of flexibility or slop, right? We're designing things fairly close to the mark, and so if things don't work all the time, we're in trouble. Now, metering data can be used to monitor energy, power, flow data in real time to assist facilities operations in optimizing equipment use. Okay, those of you who are involved with LEED, measurement and verification, my understanding is the new version of LEED is now a mandatory requirement. Is that correct? Okay. What is the biggest pain in LEED? Okay, not putting the bicycle rack in, but measurement and verification. Okay, with BACnet, you can now do M&V because devices can come with metering on board. It's rare now to see a speed drive, a chiller, a boiler, circuit breaker monitors, crack units not have onboard metering. Now, it is not revenue grade metering, okay? It's not a utility meter, but it's good enough to say, this plant, my chiller plant, my boiler plant, my air handling unit plant, is consuming so many kilowatt hours. So now, and my lighting system. We've now done lighting systems where we get kilowatt hours per fixture. We know what the connected load is, and we take the difference between what it's running at right now and the connected load, and let's say we've got daylighting sensors so the lights can run at 50%. The difference between the connected load, okay, and what it's running at is the savings associated with putting in daylighting controls. Isn't that nice for facilities operations to be able to go to management and say, you know, by putting in this more sophisticated system, we saved X thousands of dollars by having daylight harvesting. And the network controls design model allows for coopetition amongst the BAS vendors who work collectively to meet the owner's needs. What's critical is that the agreement lays out who's responsible for what. Okay, the construction contract must be clear. You can't have a line in there that says all low voltage wiring is by controls, buried somewhere. And when you're going to a site meeting to argue over a change order, you can't rely on weasel clauses. It's not fair to the contractor. All right, let me go through an example. This owner has 3 BACnet vendors who offer BAS equipment and services. Each project that we're going to show you was done, or is currently being done, as separately as funds become available. There are different consultants on each project. So here's the list of projects. We've got a VAV box renovation. We've got a booster system. We did the they had got some ARA funds and they replaced the boilers. Chiller plants had to be replaced, fire alarm upgrades, some rooftop units, IT server room and a UPS, a humidifier for the print shop, the electric, had to put in a whole electric plant for the new chiller plant, transfer switches. It's a facility that requires generator power, parking lot lighting, and some air handling units. Each one of these projects was done separately. And different vendors were involved in doing the controls, and different vendors were involved in supplying the equipment. So what we now have a series of plants. We have a chiller plant, a boiler plant, a lighting plant, fire alarm plant, and so on. Each plant has a BACnet IP interface that allows for data in the plant to be exposed via BACnet. Remember what I said is that in the case of the chiller plant, the automation contractor for the county, and there's one vendor that does all the graphics now, we had a separate contract to award that, okay, does not control the chillers individually. The chiller plant manager, provided by the chiller supplier, controls the chillers. And it controls the speed drives, and it has the flow meter, and it sees the refrigeration monitor. It's got all these other equipment that make up the chiller plant are all controlled by one controller. And BACnet IP was designed to run on the enterprise local area network, and all these BACnet plants are on the local area network. The IT department allows remote access to these plants by authorized contractors using Citrix. So we got a problem with the chiller, and it's July. And these things never happen at a convenient time, as you all know. And the chiller technician is 100 miles away. Well, he or she can browse in with their laptop, look at it, see what's going on, try and make a fix, or direct the owner's staff to do something, and he'll get there next week. By doing each of these jobs as a BACnet device, these systems can be added to the BAS front end as they're completed and brought online. Let me show you the next few slides on how the chiller plant was put together. So there are 3 chillers, 2 new ones and 1 existing one that was upgraded. There's a water treatment monitor. Refrigerant monitor is a BACnet device. All the chiller pumps are BACnet devices. And there was 1 contractor that provided the plant controller, and then there's real-time energy monitoring for the chiller plant. And each component was by a separate supplier. In the electrical world, and I'll use some names, there's Siemens, there's Eaton, there's Schneider, and they will provide products from the substation to the breaker panel, right? So generally, you know, the electrical gets one price from these guys, and if it's going to be a Siemens, it's Siemens top to bottom. Well, there isn't a chiller manufacturer that makes a boiler. Okay, and to my knowledge, no chiller supplier makes a refrigerant monitor. In the HVAC world, it's not like that. There's all different companies doing different things. So what we have is up the top there's 3 cooling towers. We have 3 chillers. Each chiller is a BACnet device. The VFDs are BACnet. So each device now is a BACnet device. The water treatment system is a BACnet device. Now, one of the issues that we didn't do on this job, because I wasn't aware of it, is that this particular device has its own built-in water meter, so we could have metered make-up water via BACnet. Didn't know that at the time. The refrigerant monitor is a BACnet device. Now, for those of you who are engineers, there's a code called ASHRAE 15, okay? There are hardwired requirements that have to be met. If the refrigerant monitor goes off, the exhaust fan must run, there's strobe lights and other things that have to happen under the code, okay? None of that is done via BACnet, okay? That's all hardwired separately, but we find out when there's a problem. So, we can now use the data from the chiller to find out what the problem is. So, these are fault codes that we generated during the commissioning process. So fault code 12 came in, and what the controls contractor did was, this document is a PDF of the BACnet troubleshooting guide for the chiller supplier. And so there's a link on the graphic that when you get a fault code, okay, you can open up the PDF document and see fault code was an external fault. And then it'll give you instructions here, who to phone, is this a critical fault, do I have to shut the chiller down? Because some faults, the chiller will shut itself down and restart itself back up again. Other faults, it shuts it down until somebody goes there. Here we have a VFD, and I'm coming back to the real-time energy monitoring. So, in the automation system, we see the kilowatt-hour counter, and that's the same value, kilowatt-hours, off the speed drive. Okay, so we can now, and I'll show you next, we can now add up all the energy consumption of the chiller plant via BACnet. So, here we have the chiller power, pump power, cooling tower pump power. We know the total tonnage. So we now have real-time kW per ton. Now, the condenser pumps are constant speed devices, so we calculate a kilowatt-hour value from the amps that are read by the current transducer. So, what we see on this graphic is we see the Monday to Friday 24-hour total. We see the Saturday, Sunday total. I don't mix Monday to Friday with Saturday and Sunday because this facility is an office complex that runs Monday to Friday. Okay, because to jump ahead, if we alarm the data based upon what we see on the weekday from what we see on the weekend, okay, we'll get nothing but alarms, right? So we treat weekends separate from weekdays. And the alarming is very simple, okay? Are we doing better yesterday than today? And we have the running cost right here for the facilities guys to see. Costs $1,583.16 at 8 cents a kilowatt hour to run the plant. And from a facility standpoint, you know, if you said, well, the plant consumed 10 gajillion gigajoules, what does that mean? Okay, $1,500. Okay, I know what that means. Okay, so now what can we do tomorrow to make it better? Because sustainability is like going on a diet, okay? It's taking little steps. We may have goals for sustainability, but the question is what are we going to do tomorrow? Maybe we could make that 1,490 tomorrow, okay? Or maybe we're going to end up being greater because the temperature is 110 degrees outside, and okay, there's, you know, we have to do what we have to do to keep the people cool. All of this data is being logged to an energy dashboard, okay, so that bean counters and finance guys can look at it. From the facilities operations side, it's basically weekly data. Let me show you an example here. This happened to me just very recently, actually. This happens to be daily water consumption. Monday, Tuesday, Wednesday, Thursday, Friday, and this facility only operates on the weekdays, so the water consumption on Saturday and Sunday should be low, right? Nobody's in the building. Now, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. The next week, leaky tap. Okay? Now, unfortunately at this point, you know, the barn door is left open, the horse is gone, but what do we do next week to make sure this doesn't happen again? As opposed to getting the water bill at the end of the month, quarterly, or however the utility reports it, and saying, what happened 3 months ago? Well, the question is what did I have for breakfast this morning? Right? This way we find out fairly soon, and we can now alarm this data. So we can say if this changes more than 10% or 20%, set what your range is, send an email to the facilities guy. Okay? I mean, looking at this is kind of like your baseline of consumption. Okay? Looks like it went up on a Wednesday. Don't know what happened on Friday, but we know we did some diagnostic work and we found out what happened Saturday and Sunday, and the tap got fixed. BAS designs must now be smart grid ready to meet the ASHRAE 201P interoperability standard. Think of a building like the Death Star, for those of you who are Star Wars fans, right? And when our heroes went to try and C-3PO and R2-D2 tried to get our heroes out of the detention center, they didn't go down to the detention center and push a button. They made a network connection, okay, and gave a command, a life safety command, okay, to unlock the jail so that they didn't get eaten by the monsters. Okay, each one of these systems in the building now can be set up to respond to a demand response event. Price of electricity is going to go from 8 cents a kilowatt hour to 15 cents a kilowatt hour tomorrow afternoon. What can we do? Well, we can dim the lights. We may be able to raise the supply water, the chilled water set point a bit. Whatever it takes to get past that demand response event without disrupting our people. Now, we may also say this is a mission critical facility and we're going to pay the freight, whatever it is. We're not going to do anything. But at least this way, we know what's going on. And each one of these devices now via BACnet can participate in that demand response event and report back whether or not they've curtailed themselves, the speed drives have slowed, the motor has slowed down, or whatever they've done to save energy or to minimize the energy cost during the short-term period that the price went up. And then what's happened with the ASHRAE standard is that there are 4 types of devices: a meter, an energy manager, in this case a thermostat, a generator like a photovoltaic cell panel, and a load like a lighting system. So we may turn, with the energy manager, we may change the temperature. We're metering what the data is. That load may be reduced, and we may use the photovoltaic to dump power to run some system. So you can have different vendors providing these different systems, okay, so long as the rules are clear as to how it gets done and that each vendor knows what is expected in terms of the BACnet interface and who's supposed to wire and install what. Thank you for your time. So we have a few minutes for questions. People have questions you'd like to? Yeah. On a BACnet internetwork, it's 4 million and something, 4.1 million. It's really limited by the bandwidth you have, but I can tell you we've done studies and that BACnet contributes very little bandwidth to the network because we're not sending what's the temperature, what's the temperature, what's the temperature. You're polling that on a regular basis. What consumes bandwidth on an IT enterprise LAN is CCTV. Right? Video is what consumes bandwidth. Other questions? Yes, the slide presentation will be uploaded to the NFMT website. You've probably been to other sessions about getting your credits and how that happens. Well, thank you very much. I appreciate your time.